Okay, hi everyone. We are back and we are going to have some fun. Today we are going to talk about, okay, that's got to go away. That has to go there. I don't know if it matters. We are going to talk about finding the zeros of polynomial functions. And some of this you already know, but I'm going to show you some other techniques to use that let you do more difficult things. And it helps you to find all the factors of larger polynomials other than an x squared type function. So let me get a new page. Okay, and first we have to recall something super important and really difficult. Oops, 2517 over 8. If we were going to do this division, we would do 8, 2517. And we would say 8 goes into 2. No. 8 goes into 25. Yeah, 3 times. 3 times 8 is 24. Subtract, we get a 1. Bring the 1 down. 8 goes into 11 once. Multiply. 8 times 1 is 8. Subtract 3. Bring down the 7. 8 goes into 37. Let's see, 8 times 4 is 32. So that's the best we can do. So 32, subtract, and we get remainder 5. So I could write 2517 over 8 equals 312 plus 5 over 8. That's how you write the remainder. The remainder over the divisor, that guy right there, right? And if we wanted to have some extra fun, I could multiply both sides by 8 to get rid of this. And we'd get 2517 equals 312 times, this side would be multiplied by 8 as well. So the 8 would go into 312. And the 8 would go into 5 over 8, but those are going to cancel. So this is another way to represent 2517 as 312 times 8 plus 5. Okay, long division. We did that a long time ago. And that's why I wanted to do it here, because we need to remember that process because we're going to do it with polynomials. Okay? Now, let's say I have x squared minus 3x minus 4 divided by x minus 2. Well, that's not so easy to do. So I'm going to go through and do the division just like we did. The top thing's going to go in here, x squared minus 3x minus 4, and the divisor is going to go outside. Okay, now here's the process. I look at x. How many times does x go into x squared? Meaning, what do I have to multiply x by to make it look like this, x squared? Well, I got to multiply it by x. I'm going to put it over the other x terms. X times x is x squared minus x times 2 is 2x. Now, I am going to give you, hold on, anybody listening? Okay, I'm going to give you the Cheverton secret here for doing this that'll keep you from making silly mistakes, okay? And here it is. Change the sign in the lower line and add. What was that? Change the sign in the lower line and add. Oh, okay. Change the signs in the lower line, and instead of subtracting, adding. It's always easier to add, especially with negatives, than it is to subtract. This will come out to be 0, as it should. Minus 3x plus 2x is minus x. I know some of you are going to think, come on, Mark, that's stupid. And you're going to just subtract, and you're going to make a minus sign error, and I will probably say, haha. So trust me, change the sign in the lower line and add. That's how I learned it. Okay, x goes into minus x. Let's see. Wait, did I do that right? I don't think I did that right. Let's go back a step here. Let's get rid of this. I think I made a mistake. So x squared. Oh, I see why it's plus. Let's leave it like this. Okay. So I did it right. X squared minus 2x, change the sign in the lower line and then add. I get 0, I get minus x, bring down the 4. Now, how many times does x go into minus x? Meaning, what do I have to multiply this by so it looks like that? And I'd have to multiply it by a minus 1. Okay, multiply. Minus 1 times x is minus x. Minus 1 times minus 2 is plus 2. Let's get rid of that line because it's annoying. There we go. Okay, change the signs in the lower line and add. 0 minus 4 or minus 2 is minus 6. Oh, here's our remainder. So we end up with x squared minus 3x minus 4 over x minus 2 is equal to x minus 1 minus 6 over x minus 2. Okay, that's what this is equivalent to. Now, if I want to have some extra fun like I did before, I'm going to multiply by x minus 2 to get rid of that denominator so I can represent it in a different way. Okay? And here they're going to cancel and we're just going to get x squared minus 3x minus 4. Over here I'm going to distribute. So this will be x minus 1 times x minus 2. And when I multiply here, they'll cancel and I'll get minus 6. So here's another way to represent this result of this equation is by doing this. And there's homework problems that will do this frequently, that you have to multiply by the denominator here to get it to spread out like this. Okay, this is polynomial division. And as long as you stick to the steps, they'll all look the same, even if the functions are totally different. There's a few little tricks, so we got to be careful, but we'll see. Okay, so let me remind you also, if I have f of x equals 3x squared plus 7x minus 20, and I want to graph this. Well, let's see, it's x squared, so it's a parabola, so it opens up. It has a positive in front, that's how I know it opens up. And it has a y-intercept of negative 20 somewhere down here. I don't know where. We'll call it there. And if I were to factor this, and these are inconvenient to factor when there's a 3, you might choose to use the quadratic equation, but it can be factored. We haven't really talked about how to do that, but it can be done. But I will tell you the answer is, this is, oops, 3x minus 5 times x plus 4. That's what it is. And again, if I want the x or the y-intercept, I set x equal to 0. And when I set x equal to 0, we just get minus 20, like I said. Okay, for the y-intercept, oops, the x-intercept, sorry, we set y equal to 0. Okay, so I put a 0 here. The only way this can be 0 is if 3x minus 5 equals 0 or x plus 4 equals 0. So let's see, I'll add 5 to both sides. So this will be 3x equals 5, so x equals 5/3. And over here, I'll subtract 4 to both sides. X equals minus 4. So here's our x-intercepts at minus 4 and at 5/3. So this function must go something like that. Okay? But the important thing is these x-intercepts can be hard to find because you don't know what the factors are. And this is where finding the factors of it by taking 3x squared plus 7x minus 20 we can divide it by something and see if the remainder comes out to be 0. Choosing x plus 7 as what we're going to divide by is a pretty bad choice, because this needs to be one of the factors of that thing, and 20 isn't divisible by 7. It's certainly divisible by 4. So this is how we're going to use polynomial division to help us find the factors of a polynomial, so the function is easier to graph when this thing is inconvenient and hard to factor. Okay? So x squared minus 3x minus 4 over x plus 1. So go ahead and set this up. I'll pause it and set up your division. Go ahead, pause. Okay, so I'm going to do x squared minus 3x minus 4. I'm going to have x plus 1 over here. That's how I'm going to set it up. And I'm going to look at x squared and say, what do I have to multiply this guy by to make it look like x squared? I have to multiply by x. X times x is x squared. X times 1 is plus 1. Okay, change the sign in the lower line and add. So it's not going to be that anymore. So that'll give me 0. Minus 3x minus x is minus 4x. Bring down the negative 4. Now, how many times does x go into minus 4x? What do I have to multiply this by to make it look like that? And it would be minus 4. So let's see, minus 4 times x is minus 4x. Minus 4 times 1 is minus 4. Change the sign in the lower line and add, and we get 0. Yay, no remainder. That means this is a factor of this guy. So now I can rewrite this. X squared minus 3x minus 4 over x plus 1 equals what we got from the division, x minus 4. And again, I can multiply through by the denominator because I'm cool, and I can do that. And the denominators will cancel on this side, and we'll get x squared minus 3x minus 4 equals, and on this side, we're just going to get x minus 4, x minus 1. Here are the factors of that polynomial. We got them written out for us. That's why we multiply through by the denominator, so we can see it in factored form. Okay? That's kind of an easy one. I agree. Okay, let's try 3x squared plus 7x minus 20 over x plus 4. Okay, set it up. 3x squared plus 7x minus 20 over x plus 4. And let's see, x goes into here. We'd have to multiply that by a 3x. Okay, 3x. That'll make a 3x squared plus 12x. Okay, change the sign in the lower line and add. We get a 0. 7 minus 12 is minus 5x. Is that right? Yep. Bring down the minus 20. Okay, x goes into minus 5x. How many times? What do I have to multiply x by to make it look like minus 5x? I have to multiply it by minus 5. So I'd get minus 5x minus plus 20. Okay, change the sign in the lower line and add. I'll get 0 and I'll get minus 40. Bummer. We got a remainder. So I would write this 3x squared plus 7x minus 20 over x plus 4 as 3x minus 5 minus 40 over x plus 4. Okay? And if I multiply through by the denominator like I've done before, so I'll multiply this side, multiply this side by x plus 4. and multiply this side by x plus 4. These will cancel, and we just get 3x squared plus 7x minus 20 equals, this one will get multiplied into this piece, 3x minus 5, x plus 4, and then it'll get multiplied here, and the denominator will cancel. So here it is in factored form with its remainder. So I can represent it two ways. I could represent it like this, or I could represent it like this. I got to show the equation, but if the problem says divide this polynomial by that one, your answer is going to be the part in green, okay? Because that's the solution to that division problem. So that's what you're going to answer on a test or a quiz or something, okay? Let's go to a new one. Let's show you a new way. Because this way is kind of long, actually. We're going to do this. 2x cubed. Let me use a different color because we can't really see that very well. There we go, a little dark green action. Okay. 2x cubed minus 3x squared minus 5x minus 12 all over x minus 3. Okay? So I got x minus 3, 2x squared minus 3x, 2x cubed minus 3x squared minus 5x minus 12. So this will go into here. See, I got to multiply x by 2x squared in order to make it a 2x cubed. Multiply minus 6x squared. Change the sign in the lower line and add. So this would give me 3x squared. Bring down the 5. Okay, x would go into here. See, I'd have to multiply that by 3x. So that would give me a 3x squared and a minus 9x. Change the sign in the lower line and add. 4x. Bring down the 12. Now this will go into there plus 4 times. So 4x minus 12. Change the sign in the lower line and add. We get goose egg. Nothing. Awesome. Okay. So this is the standard long division method. Now I am going to show you the synthetic division way. And the first thing you do with synthetic division is you take the denominator and you set it equal to 0 and you solve for x. So I would do plus 3 to both sides, x equals 3. Okay? That's step 1. Step 2, write all the coefficients. I kind of spelled that wrong, but you'll have to trust me. Coefficients. Coefficients. Okay, so the coefficients will be over here is a 2, a minus 3, a minus 5, and a 12. 2, minus 3, minus 5, minus 12. You want to space them out some so they're not right on top of each other. Put a line above it, leave a space, and put a line below. Okay? Now over here, we're gonna, oops, not gonna write it there because I need that space. Step 3, put answer from 1 in the corner. Think of this as the penalty box here. There, put them in the penalty box. Okay. Now, the rule is you're always going to get, let me pause for a minute here. Okay. So we're always going to start with a 0 here. And then we're going to add. Okay, just like we changed the sign in the lower line and add. Notice this was a -3, but we put a +3 here. That was our change the sign. By doing that, we've changed the sign in the lower line, and now we're going to add. So I get a 2 here. This number goes up here. Multiply. 2 times 3 is 6. Add 3. Up here. 3 times 3 is 9. Add 4. 4 times 3 is 12. Add 0. Oh, there's our remainder, 0. Hey, look at that. We got the same thing. So I just did the exact same thing, and the answer I got from doing this, let me get rid of that stuff here. Sorry, number 3. We got to say bye-bye. So the answer I got from 2x cubed minus 3x squared minus 5x minus 12 over x minus 3. This was +3. It's always opposite from the sign here. I always take the denominator and set it equal to 0 and solve for x. I got, this is x squared, this is x, and this is the constant. I got 2x squared plus 3x plus 4 and no remainder. And notice, this is exactly the same as what we got up here. But this is a whole lot less work than all of this. I can do a polynomial here in seconds, and here it takes me minutes to do it. So this is much faster. Students don't like this way because they like to see all the parts here, and that's great. But I'm telling you, this way is much easier, and you'll want to get good at this because this will be really helpful. If you have to do this on, I'm sure you had to do some, maybe you had some polynomial division on the SAT. If you had known how to do this, it would have been really quick. If you're thinking of graduate school and you're going to take the GRE, you definitely want to know how to do this for the GRE. Or the MCAT or the LSAT or something, right? This is a very fast way to do a problem to save you a lot of time on a test. Okay. Let's try one more. So is it the same one? It is, okay. Now, let's do this one. This is problem number 8 out of the book. I don't know if it's the same problem. This is problem number 8 from the 8th edition, and we're using the 10th edition, so who knows if they're the same or not. 2x to the 4th minus 5x cubed plus 7x squared minus 3x plus 1. Okay, step all over. We got to know what we're dividing by. X minus 3. Okay, step 1, x minus 3 equals 0, x equals 3. This is what's going into the top, into the penalty box. Okay, so 2 minus 5, 7 minus 3, 1. Now, if you write any of these numbers incorrectly or get a sign wrong, you're going to be really sad because it ain't going to work. You'll get the wrong answer, which is certainly true if you do the long division way also. Okay, first thing gets a 0. We get a 2. You got to make the sound or else it doesn't work. 2 times 3 is 6. Add, we get a 1. We get a 1 up here. 1 times 3 is 3. Add, we get a 10. 10. 10 times 3 is 30. Add, we get 27. It's getting bigger and bigger. 27. Multiply, times 3 is 81. We get 82. Remainder. So 2x to the 4th minus 5x cubed plus 7x squared minus 3x plus 1 all over x minus 3. This was the original problem. Equals, I can write it from here. This was x to the fourth. So this must be x to the third, x to the second, x to the first, and a constant. 2x cubed plus x squared plus 10x plus 27 plus 82 over x minus 3. That was really fast. If you're going to do it long division ways, it's going to take you a while. And I encourage you to try it the long division way and see how long it takes you. This is much faster, okay? Now I'm going to give you an example that I am not going to solve for you. And if you want to see the solution, you're going to have to come to office hours. Ha ha. So I get 2x to the fourth minus 2x plus 3 divided by x minus 1. How are we going to do this? Let's see, step 1, x minus 1 equals 0, so x equals 1. He goes in the penalty box. Now I write out my coefficients. 2, negative 2, 3, 1, and you are super sad because that is incorrect. Because you have to make room for the terms that are missing. The coefficient on x cubed is 0. So this should really be 2x to the fourth plus 0x cubed plus 0x squared minus 2x plus 3. So our coefficients are 2, 0, 0, minus 2, 3, and we go into the penalty box. Okay? So that's what you need to do. You gotta put spacers in for missing terms. That always seems to be on a test or a quiz to see if you paid attention and you did this. The likelihood of that being on a test or a quiz is gigantic. So you should pay attention to this, okay? So if you want to see what the solution is to that, you need to come and see me. Okay, now we talk about bounds for the solution. And there's an upper bound and a lower bound. Meaning, if I try a number, like if I have a big old long polynomial, let's see, 2x to the fourth minus 7x cubed minus 8x squared plus 14x plus 8. And I want to know, geez, I got to find the factors for this. I don't know what it's going to be. I know there's going to be a 2x somewhere because of this. And then there's an x, x, x. I know there's 4 factors because it's x to the fourth. So there's going to be 4 roots, 4 zeros to the function. But I don't even know where to start. I mean, I don't even know how to attack this. I know that I have to have things that are factors of 8. So 2, 4, 8, 1. There's a limit to what numbers can go in here, but I don't have any idea which ones I'm going to use. So factoring this guy sucks. It's hard. So what we do is we do a test. Let's say I'm not very bright. I try x minus 5. I want to know if that's a root. Okay, so I do I do x minus 5 equals 0, so x equals 5, penalty box. 2, any terms missing? 4, 3, 2, 1, 0, no. 2 minus 7 minus 8, 14, 8. Now I know that's a really bad choice, maybe, because you'd think it has to be a factor of this, but maybe it's a 5, there's a 5 and a 2 and an 8. 5 times 10, no, I don't know. Let's see what happens. So bring down the 2, multiply, add, multiply, 3 times 5 is 15, add, I get a 7, So the 7 goes up here. 5 times 7 is 35. Add 49. 49 times 5 is 245. Add, I get 253. Notice, all of these terms are all positive. When that happens, that means there are no roots greater than whatever we tested. So when all of them come out positive, this number is not a root, and anything above it is not a root. We should not bother to test 8, because when these come out positive, that tells me this number is an upper bound, and there's nothing above that that's going to help us. Okay? So make a note. When all the answers to the synthetic division are positive, this number is too big, and there's no numbers above it that will work. Okay? All positive, upper bounds. So for the upper bound, all positive answers. Okay? Now, if we do, let's try something else, because that was fun. Don't get me wrong. I enjoyed it, even though it was a failure. Still enjoyed it. Okay. Now, well, let's try -5. What the heck? That's got to be fun, right? Okay, so I do, oh, I'm sorry. So let's try x plus 5, which means x plus 5 equals 0, x equals -5. So I'm trying a smaller number. Okay. Okay. So -5. Oops. Penalty box. 2, -7, -8, 14, 8. Okay. Put a 0. We get a 2 when we add. Goes up here to 2. 2 times -5 is -10. And that's a -7. So that gives a -17. So -17 goes up here. Multiply. That's 50. What is that? 85. Positive, because it's negative times negative. I add, I get plus 77. 77. 77 times -5 is minus 385. I'm seeing these numbers get bigger. So add these up, we're going to get minus 371. It's certainly not converging to a solution. Maybe it will. Okay, -371. Multiply. Holy crap, that's a big number. 1855. Add 1863. Okay, I'm going to go out on a limb and say x plus 5 is not a root. Okay, and notice you have negative signs here and you got positive signs here. Alternating positives and negatives down here. That means it's a lower bound. There's nothing below that that's going to work. Okay? So we know it's not above plus 5, it's not below -5. So now let's try something else. This is a great way if you're trying to factor this big ugly thing and you have no idea what the roots are. This lets you narrow down the hunt. Let's try x minus 2. Oops, let me get my purple back. I'll get the exact same shade. There we go. So I'm going to try x minus 2. Okay, so forget about that. X minus 2 equals 0. X equals 2. So 2 goes in the penalty box. 2, negative 7, negative 8, 14, 8. Line above. Leave a space. Line below. We start with a 0. We get a 2. 2. 2 times 2 is 4. Add. We get a minus 3. Minus 3 times 2 is minus 6. Add. We get minus 14. Oh, so it's not alternating. So this is not going to be a lower bounds. So this comes up here, minus 14, multiply, minus 28. Is that right? Yep. Add, we get minus 14, and minus 14 comes up here. That comes at multiply, minus 14 times 2 is minus 28, and that comes out to minus 20. Okay. Not a root, but not an upper bound or a lower bound. It's just a failure. Okay. So you need to go around and try these. Oh, let's do one more, because this will be super fun. Now let's try x plus 2. No, we just did that. No, that's right. X plus 2. We just did x minus 2. So x plus 2 equals 0. X equals minus 2. So minus 2 goes in the penalty box. Shouldn't have been fighting on the ice. That's what you get, hockey player. Okay. 2, negative 7, negative 8, 14, 8. Line on top. Leave some space. Line on the bottom. We start with a 0. 2. 2 times minus 2 is minus 4. That's a minus 11. Getting big already. That's a problem. Minus 11 times 2 is plus 22. So plus 22. So we add those. We'll get 14. Ooh, that looks interesting. Okay, no, 14 times 2 is minus 28. Add. We get minus 14. Okay, put a minus 14 up here. Minus times minus is plus 28. So we get 36. Huh. That's the remainder, not a root, but notice alternating pluses and minuses. So now we know minus 2 is the lower bounds. Originally, we thought it was minus 5, but now we've learned minus 2 is a lower bounds as well. So there's nothing below negative 2. So maybe we got to try minus 1 and 0 or something. Okay, so this is the process of elimination to work out the zeros of a big ugly polynomial like this. I strongly, strongly, strongly recommend that you learn the synthetic division way, because it'll save you so much time on all your homework. But you got to practice it so you're good at it. So you need to do that. So come to office hours. I'm going to do some more of these, and I'll let you practice the synthetic division with me. If you put in the time on synthetic division, it's going to really save you a lot of headache. I can't tell you that any stronger than that. Students never believe me, and they want to do it the other way, and then they're running out of time on a test because they're having to divide some big ugly polynomial, and they're doing it the long division way. And that kind of sucks. So don't do that. Okay? If you have questions, come to office hours. Come see the example problems done, and it'll help you on tests and quizzes. And we'll see you later. Bye.